The name of this presentation is Visualizing a Systems Approach. This is a single aspect regarding the direction advocated by the Zeitgeist movement, and of interest to me since it's a key factor in understanding human decision-making and problem-solving beyond the political sphere. As you go through the materials we often reference, you will come across many terms and phrases that sound impressive and are actually fun to say. Some examples of this would be a resource-based economic model, technological unemployment, dynamic equilibrium, the scientific method for social concern, a systems approach to resource management, along with many others. We spend a lot of time in the movement speaking about the root causes to persistent problems of social operation on the planet, especially in regard to the more notable negative outcomes such as crime, poverty, war, pollution, debt, and other forms of corruption. While it's logical to understand the problems first, we can sometimes miss the focus on aspects of the solutions we propose, even though there is plenty of information available. At the foundation of what the movement advocates is a global system which can be termed a resource-based economy, made known to many of us by the work of the Venus Project in Venus, Florida. A resource-based economic model is a social structure that is global in its operation, based entirely on the Earth's resources as the starting point for societal decision-making, where all goods and services are available without the use of currency, credit, barter, or any form of debt or servitude. All social and industrial operations are arranged in what we call a systems approach, which logically treats the planet Earth as a single system it happens to be. We also advocate the application of technology to the automation of labor to free humanity from the mundane and arbitrary occupational roles which have no true relevance for social well-being. And, at the end of the day, we want to encourage a new value and incentive system through this social design which maintains a focus on attributes such as community, human well-being, relevant education, social awareness, and creativity. That's as far as I'm going to go into the overall direction, since it's far too much information to share with you tonight. Instead, I wish to spend a few minutes visualizing a core attribute of this model to give us a working understanding of one piece of the technical jargon. The attribute of focus in this presentation will be a systems approach. Our relationship to the Earth and the environments we live in is not a political issue or a religious ideal. It is a technical relationship. Separate a living organism from its surroundings and it will die from a lack of oxygen, water, and food. Organisms are open systems that cannot survive without continuously exchanging matter and energy with their environment. Since we observe systems interacting with each other as part of a whole, it is then logical to start with the unifying system of the biosphere in which we all inhabit. Systems thinking can be defined as an approach to problem solving by viewing problems as part of the overall system rather than reacting to individual problems as isolated or unrelated phenomena from the larger order. When taking is separate, such patchwork notions may further the development of unintended consequences, such as trying to resolve the problems of monetary inflation with more inflation, or trying to fight the destruction of the rainforests, or the increase in plastic waste in our oceans by more laws and legislation, rather than addressing the cause of the behavior to begin with. Systems thinking is not one thing, but a set of habits or practices within a framework that is based on the principle that the component parts of a system are best understood in the context of relationships, rather than in isolation from one another. So this brings us to an attribute that is often mentioned, which is a systems approach. A systems approach to resource management on the planet is comprised of real-time data and statistics. This approach, combined with the attributes of peak efficiency, strategic preservation, and conservation, become necessary components to what we would call a sustainable society. The process of unfolding, which you may call decision-making, is based on natural law and reason, not on political ideologies or religious notions or a group's opinion. When using a systems approach, we are arriving at decisions as opposed to making them. Making a decision is a subjective act, often based on incomplete information or affected by one's cultural bias. Our goal is to remove the basis of one's opinion as best we can by using the most up-to-date knowledge we have to align with natural processes to the best of our abilities at a given time. This is an emergent process because the body of knowledge of human understanding changes over time as new discoveries are made. There is no final frontier. So human management of the environmental equilibrium on this planet, which is an initial variable to how well society functions, comes first from understanding what the carrying capacity of the Earth actually is. It follows that the needs of the human population must be in balance with the resources of the Earth, or negative outcomes occur. So, where do we start? What is the first step to determining the carrying capacity of the Earth? Well, this is where a systems approach comes in. A logical start would be with a full survey of the Earth's resources, since we must know what we have to work with in order to arrive at any decisions. There are many natural resources to be considered, such as forests and oceans, energy, along with arable land, water, and minerals. But for the sake of simplicity, let us refer to these components as natural resources. If anyone is currently thinking, well, this makes sense, but how would it even be possible to create this kind of a global system? Or perhaps you might be thinking that the technological know-how for such a comprehensive survey is a bit too futuristic. Well, at this point, I'd like to make use of a few visual examples of current real-world technical systems that are working in this regard right now. This is an accurate visualization of many current and former NASA Earth observing satellites, with names like TRIM, Landsat 7, Terra, EO1, Jason 2, Grace, IceSat, and Aquarius. These unmanned probes are quietly beaming down information that has transformed our understanding of how the Earth works and what we know of the human fingerprint on our climate. Together, they represent an application of technology in real time, working as part of a global surveying system. Not something from Star Trek, not something 100 years away, but orbiting the planet right now. Let's look at a closer example. The satellite Aquarius is designed to take comprehensive salinity measurements of the Earth's oceans in their entirety every week. The data obtained from these measurements help answer some of our most pressing questions about climate change. Why salinity? Well, the density of the ocean water is determined from its salinity and from its temperature. Density of ocean water drives the patterns of deep ocean currents, and ocean currents drive global change. In recent decades, scientists have seen that our ocean salinity has shifted in ways which only climate change seems to be able to explain. From 400 miles above the surface of the Earth, Aquarius can detect differences in ocean salinity to within a pinch of salt in a gallon of water. With this visualization, we are witnessing an example of current technology being applied via the methods of science for environmental and ultimately social concern. The collection of all of this data can be used for understanding our environment or even predicting possible outcomes. In this example, what you're seeing was not photographed from space. Every pixel here was calculated by the GEOS 5 supercomputer. This supercomputer can accurately model and simulate the Earth's atmospheric conditions for short periods of time. In this example, this model was giving data leading up until February 2nd, 2010, and then it proceeded to predict the atmosphere's response for the next 20 days without any further input. This model simulated real-world weather events that actually took place, including snowstorms, tropical cyclones, and many other climate conditions. Continuing these examples, the Terra and Aqua satellites gather data of the Earth's surface every 2 days. This animation shows where the world's food is grown versus where the world's food is consumed. The movie starts with global croplands, then fades to the countries that produce over 80% of the world's wheat, grain, and cereal. It then overlays the world's population density, and then fades to show the countries that are projected to double and triple their populations by the year 2050. There also exists a mineral resource data system, which is a statistical survey done by the USGS. This is the United States Geological Survey. This map is a collection of reports describing mineral resources throughout the United States. The survey actually expands out for the entire globe, but this map just shows an example, serves a purpose for this presentation. This is an example of information that would be part of the so-called geodatabase, if you will, integrating the data set into a global knowledge base of our resource management system as a function of a systems approach we've been exploring. Another example of visualizing a systems approach in action is viewing compiled data from our global resource system. Here, a member of the Google Earth community assembled this image from the CIA World Factbook showing world oil consumption for the year 2007. This chart displays exploding 3D graphs in the shape of each country, showing the relationship of oil consumption between countries. Here, the United States is showing its tremendous consumption of about 21 million barrels per day, which is almost 25% of the earthly total of 82 million barrels of oil consumed worldwide. That's daily, 82 million barrels a day. So, how would you possibly interact with such a system of immense data? Well, following the evolution of text-based search engines, which we are all familiar with today, we would interact with this vast knowledge base via computer or AI assistance. An example of a computational knowledge engine that already exists is Wolfram Alpha. This engine generates output by doing computations from its own internal knowledge base instead of searching the web and returning you links. In a resource-based system that we advocate, such a concept could easily be scaled out to include the immense amount of data that is currently collected both in the public and private sectors of the world today. Along with the many free information and data products out there via the internet, one could well ponder the question that if, with a little cooperation from our technology friends, could we actually have a path laid before us to move in such a direction? Well, who knows? But maybe the world is simply waiting for enough people to want to do so. The point is, there are many real-world working examples to show how such a collaborative social system is a technical reality and not a someday phenomenon. I'm going to conclude here with this artistic representation of this system as visualized by industrial designer and social engineer Jacques Fresco of the Venus Project, who has spent more than 70 years of his life researching such a direction. I hope this presentation has helped you understand how a systems approach to resource management could work, how we can approach problem solving beyond the sphere of politics, how we can arrive at decisions via science rather than human opinion or a majority vote, and how current technology could be applied to make such a global resource-based system a reality.